Hey guys, assalamu alaikum. Okay, so this is an introductory lecture of O-level physics. Okay, so this is our very first lecture to O-level physics. Let's get started. Alright, so in this lecture I'm just gonna talk about an overview of O-level physics. Actually not an overview but rather an introduction to O-level physics, which is actually very that might help you build upon your concepts, and in the upcoming lectures we are gonna eventually cover up further topics. Alright, so now let's talk about physics. Okay, so what is physics? Physics is actually a branch of science. Okay, this is a branch of science, and specifically that branch of science that deals with matter, energy, and their relationship with one another. Okay, so physics is actually a branch of science that deals with matter, energy, and their relationship with one another. Okay, so what is matter? Matter is actually any substance, or I should rather say any body that can occupy space. Basically, in other words, it has volume and that has some mass. Okay, so any body which has these two properties is considered matter, whereas energy is defined as the ability to do work. Okay, so basically these are the basic definitions of matter and energy. Well, they are related to one another. Matter can be converted to energy, energy can also be converted to matter, but anyways, this relationship was given by Einstein in his famous equation E is equals to mc squared, in which E represents the energy, m represents the mass or the matter. Okay, matter, the mass, and this is actually an equation that we are gonna study later on in the upcoming lectures, specifically in the very last chapter, radioactivity. Okay, where there we have a few numericals based on this formula. For now, well, you don't need to know it, but it's actually a formula that relates both of them. Okay, so energy and matter, they can interact with one another. Okay, they can be interconverted as well. So basically this is what physics actually means. It is a branch which deals with matter and energy. Physics can also be subdivided into further branches. Okay, and these are just a few examples of these branches of physics. Okay, we can have general physics, we can have thermal physics. Thermal, well, actually, as the name suggests, it's the physics that is related to heat energy. Okay, that is related. Therm means heat. Therm means heat. So the physics related to heat. Okay, the transfer of heat, the form, the ways by which heat is transferred from one body to another, etc., etc. All of that, we have a whole detailed chapter on thermal physics as well, which we'll be doing later on. Okay, waves, physics can be applied to waves as well. By the way, light and sound, both of them are waves as well. Okay, they both have wave properties, and by the way, we also have a chapter on waves. Then electromagnetism. Okay, so physics can also be applied to electromagnetism, meaning there are light, for example, is an electromagnetic wave. Well, we are going to talk about that in detail. And then we can have atomic physics, we can have nuclear physics, and so on. We can have multiple branches of physics. These are just a few of them. Okay, well, you are not expected to learn them because you are eventually gonna learn them anyways, because these are gonna be repeated so many times that you'll learn them eventually. Okay, so now let's move on. This was a bit about physics. Okay, so now coming to the main discussion, physical quantity. Okay, so what is a physical quantity? Okay, so basically physical quantity is defined as a property of material, that of any material, of any substance, that can be quantified by measurements, or that can be measured in numbers. Okay, so basically quantified, quantity means numbers, right? Anything that can be converted into numbers. So basically any that particular property of a material which can be converted to numbers by measurements. Okay, that can be measured. Any property of a material that can be measured is the physical property or the physical quantity. Okay, physical quantity. So now I'll give you an example of, let's say we have mass. Mass is a physical quantity and we can measure mass as well by using a mass balance, and this mass balance will give us a numerical answer, right? The numerical answer that this mass balance will give us would be, for example, 5 kg. So if you look at this example over here, what is it? What does this contain, this answer? 5 is a number and kg, this is a unit, right? 5 is a number. So basically physical quantities contain a number and a unit generally. Okay, well, there are further types of physical quantities, scalars and vectors, that we'll be doing on in the upcoming lectures, but over here generally all the physical quantities, they possess a number because that's what really defines them. Okay, it's actually a property that is measured in numbers and also has a unit. Okay, let's move on. The next definition that you guys are expected to know is SI unit. SI, well, this actually means International System of Units. International System of Units. So as the name suggests, this is a set of units which is used internationally as a standard. Okay, well, why do we need to use a standard that is used internationally? Why do we need to standardize it? Well, in order to get the most reliable measurements. Okay, and we can easily compare the measurements. Well, actually this was important to make an international standard of units because every country across the globe might have their own set of units in which they might measure a particular physical quantity. For example, mass can be measured in pounds as well. Mass can also be measured in grams, and there are several other units. For example, bigger masses, they can be measured in tons. Okay, so basically tons, grams, pounds, etc. These are all the different types of units which are there, but they are not standard. Okay, different countries might use different types of units. So in order to make them standardize the units, and in order to get the most reliable measurements, the scientists around the world, they agreed to use the international standard of units or the international system of units, which will give them the most reliable measurement. Okay, this is actually a very important part because now the SI units, they are gonna be used throughout the physics that you are gonna study in your upcoming lectures and upcoming years. Basically, even in your A levels, the SI units are used. Even in your O levels, the SI units are used. Okay, across wherever you study physics, SI units are used most frequently. So this is actually a very important part. Okay, now coming down, fundamental SI units or fundamental physical quantities and their SI units. Fundamental, which are their SI units, are called base units. Okay, so basically we have 7 types of fundamental physical quantities. Okay, first of all, what are fundamental physical quantities? So basically, let me zoom out a bit. Okay, so basically fundamental physical quantities are pure physical quantities. Okay, they are pure physical quantities that can be directly measured, directly, and they are not derived from some other quantity, measured directly, and they are not derived from other physical quantities, physical quantities. I'll just give you an example. For example, if you have the formula for speed that you guys have been studying in your lower classes. So speed can be written as the ratio of distance to time, right? Distance traveled per unit time is the speed. Over here, if you look at this formula, speed is a physical quantity. It can be measured by a speedometer. Distance is also a physical quantity and can be measured by using any instrument, for example a measuring tape or a meter rule for smaller distances, etc., etc. There are several other instruments that can be used to measure the distance, and time can be measured using a stopwatch. Now basically over here, the distance and the time, these are two physical quantities, the two fundamental physical quantities. Distance is length and time is right over here. Both of them are fundamental physical quantities. Now both the distance and the time are used to derive a third physical quantity, which is the speed. Okay, so this speed, since it is derived from the fundamental physical quantities, so that's this type of physical quantity is known as derived physical quantity, whereas these quantities which are not derived from any other quantity but rather they are only measured directly by using an instrument, these physical quantities are the fundamental physical quantities. Okay, now an important fact to remember over here, all other physical quantities in physics, they are derived from the 7. Okay, so all other physical quantities which are out there in physics, they are all derived from the 7 fundamental physical quantities. Okay, and the 7 fundamental physical quantities are listed right over here. Let's go over them one by one. The very first one is mass. Mass can be measured using a mass balance. Okay, and the SI unit, the unit which have been agreed to used internationally by the scientists, is kilograms or kg. By the way, this k is a small k. Okay, it has to be small, and this g is also small. They both of them are small. They are lowercase letters. Now the second one is length. SI unit is meters, and the instrument is measuring tape. It can be a meter rule as well for small distances, meter rule. We can also have half meter rules. We can have measuring tapes, and well, for even small distances, there is another instrument called ticker tape. Then we have the time. Time is measured by a stopwatch or a stop clock in case of very long distances. Actually, pendulum clock can also be used over here, and the SI unit is second. Current is also a fundamental physical quantity. Unit is amperes, and ammeter is a device that uses it. Temperature can be measured in Kelvin. Kelvin is actually the SI unit of temperature. Okay, we do have other units too, for example degree Celsius, degree for Fahrenheit, etc., etc., but the degree Celsius and degree Fahrenheit, they are not the SI base unit. Kelvin is the SI base unit. And guys, remember, this is a capital K. Okay, this is not a small k. Small k is used for kilo, but this is a capital K, meaning Kelvin, and there is no degree sign over here. Okay, this is an important point to remember over here. Thermometer is the instrument that uses it, that measures it. Okay, and there are several different types of thermometers. We'll be doing that in detail in this chapter. Temperature is a whole chapter on temperature in the upcoming lessons. Then the sixth physical quantity is the intensity of light. Okay, luminous intensity, basically the brightness of light or the intensity of light. That is also a physical quantity, can be measured directly. The unit is candela. CD actually. Okay, CD is a symbol of the unit. Candela is the SI base unit of intensity of light. Photometer can be used to measure the intensity of light. And the last but not the least, the amount of a substance, which is known as mole. This is also something you guys will be doing in chemistry. Well, there is a lot of calculation related to moles, but over here in physics we don't have a lot on moles. We just need to know that it's a physical quantity. Moles, its unit is also moles, MOL, and mole cannot be measured directly. This is an exception. Okay, this is a physical quantity that cannot be measured directly. It has to be calculated. Okay, but it has a certain formula which you guys will be doing in detail in your chemistry lessons. Yeah, this completes our discussion for this class. In the next lecture we'll be talking about prefixes. Okay, so thank you so much, guys. If you are new to this channel and you haven't subscribed yet, so please do subscribe and click the bell icon. Okay, and if you have any question, so leave it in the comment section and I'll try getting back to you. Okay, thank you.